The first one is reflection across the x-axis. The second one will be reflection across the y-axis. When you have functions that have negatives, if the negative is outside of your function, you can think of that as being a reflection across the x-axis. Okay, so again, if we take our generic y equals x function, the parent function here, if we wanted to find what y equals negative x looks like, again, this negative can wind up being thought of as being either outside the function or inside. Again, it's probably easier to think of it as outside. If we apply the rule for the outside, okay, we're going to take this graph and we're going to reflect it across the x-axis. So again, here is our x-axis. So the way that if we reflect this vertically across this axis, this set of points gets moved down here, and this set of points gets reflected up above. So this winds up being our y equals negative x graph. It's just the other graph reflected across that x-axis. And now, would we have gotten the same thing if we had used the rules for reflection across the y-axis? Again, here's our y equals x. If we were taking y equals negative x, if we took this set and reflected it across the y-axis, and then this set reflecting across the y-axis, again, we wind up with the same thing. Okay, it doesn't really distinguish on these. Okay, but let's take a look just really quickly once again at the absolute value. Okay, so here's our absolute value graph. Okay, if we wanted to find what the equation of y equals absolute value, negative absolute value of x is equal to. So here it's clear that this negative is outside of our function, right? The function is absolute value. Right? And so what we're going to do is we're going to reflect it across this x-axis. Here's our x-axis. So this V shape gets reflected down. So that's what our graph of y equals negative absolute value of x would look like. Okay? And we could do the same thing down here. If we took our basic function and we wanted to find what y equals absolute value of negative x is equal to. Now, where is this going to reflect? Across what? Now the negative is inside the function, so it's going to reflect across the y-axis. So this dashed line here gets moved over to this spot, and this orange dashed line here gets reflected here. And so this winds up being the absolute value of negative x. Now, is that consistent? Is that something you would expect? Is the absolute value of negative x equivalent to the absolute value of x? Yeah, it doesn't matter, right? But it's consistent with these reflections.